Dalton believed that matter was composed of atoms, and he believed that these atoms were solid spheres. You can think of these as billiard balls if you want, but they're solid and they're indestructible. So one of his first ideas was that all matter is composed of atoms. And everything that you can pick up, move, feel, has weight, has atoms in it. These atoms, by definition, are the simplest building blocks of the matter. And he believed that atoms were unable to be broken apart, and so they were indestructible. And he also believed that atoms of one element are identical. That means that if you were to look at an iron atom and compare it to any other iron atom, it should be the same. And what kind of follows from this is that atoms of different elements are not the same. So they're different. I know that's pretty simple. These relate to each other. And the last one is that every time we have different compounds, those compounds are formed, or all matter is made and formed from just different combinations of atoms. Now, these are some of the basic ideas of Dalton. Now, we don't entirely believe all of these. We still believe that all matter is composed of atoms. The idea that atoms are indestructible, for most everything that happens on a daily basis, atoms stay together. They are pretty indestructible. But we know of exceptions to that. Nuclear reactions, decaying radioisotopes are examples of it, and even something simple like an ion, where electrons can come and go. Atoms of one element are identical. We don't currently believe that because sometimes we can have isotopes. And isotopes are when we have a different number of neutrons. And atoms of different elements are, and I should correct this, elements are different. That we still believe. The last one we also believe, which is all matter is made of by combining atoms in different ways. We still believe that. Now, he used other scientists' evidence and observations of his own about the atmosphere, but the big one that he used as evidence was the idea of law of definite proportions. And it was this kind of observation that was always found when you were looking or analyzing compounds. And the mass of elements in a compound was always a constant ratio or percentage. And Dalton was able to explain that using his atomic theory. And the way he did that was, if you imagine that two atoms connect with each other, and we're going to say one of the atoms weighs 1 unit and the other atom weighs 3 units. Together, they weigh 4 units of mass. So the ratio of mass, or percent of mass of the one atom, first atom, is 25% of the total mass, because 1 divided by 4. The percent of mass of the second atom is 75% of the total compound. Well, let's say we didn't just have one of these molecules, we had multiples. Now, what stays the same is the ratio in Dalton's theory. So, if you have 4 of the circles, that means you have a mass of 4. Each one weighs 1. And you have 4 of the squares. Each one weighs 3. So that's a mass of 12. Together, they weigh 16. Now, 4 divided by 16, that is 25% still. And 12 divided by 16 is 75% still. No matter how much of it we have, we always have a constant ratio by mass. And that's the law of definite proportions. People found experimentally that compounds always have a certain ratio of mass of elements. And that could be explained by atoms composing all these compounds, and they couldn't be broken apart.